This video is part of a presentation about denial of service on RTC systems. This is the sixth part, which is about DoS on RTC security protection. This is the same protection that is often tasked with blocking DoS attacks. First, we get to talk about IP spoofing. Uh, an IP, an IPS like fail to ban, when configured to block any IP that is seen to be attacking the RTC system, can be a problem. The reason for this is that, especially with UDP, the source IP of the attack can be spoofed. The attacker may spoof the IP of a trusted peer, such as a SIP trunk. So now we have a demo for this. This demo was recorded in our lab environment because we did not have a server that has no egress filtering on the internet. However, I know that with Bitcoin and so on, one could acquire such ability since the internet was never really designed to protect against IP spoofing. So in our lab, we have the target machine that is running asterisk and fail to ban. We have the attacker who can easily spoof the source IP, and we have Zoiper that is used to make test calls. Then on the internet, there is the SIP trunk that is set up for the asterisk machine so that external calls could be made. It is the IP of the SIP trunk that will be spoofing in our attack. So first, we log into the target machine. And check that asterisk is actually running. Then we show that a test call can be made through the SIP trunk.
Welcome to Twilio. You have reached the trunking verification.
Then we can start Scapy on the attacker machine. Scapy is a tool that allows us to easily spoof IP addresses. I have prepared the IP addresses that are used by the SIP trunk since there is DNS load balancing in place. So then we have a zip packet that contains a zip message that is known to trigger a log file entry, and fail to ban is looking for that and blocking the IP in the log. So the Python script basically goes through all the IP addresses that it's going to spoof and then sends the same packet 100 times to each IP. We're creating the payload. So then we'll use the send button function to spoof the IP address of the SIP trunk and send the attack. So that's the command. And one can see that the asterisk errors, which are then picked up by fail to ban. And now we make a test call so that we see that the call is not going through anymore. The error on the asterisk server that you can see on the left indicates that the SIP trunk cannot be reached. If we look at fail to ban, we can see that all the IPs of the SIP trunk are actually banned. So that's Another thing that we noticed is that some attacks generate a lot of logs. And if the IPS is meant to read the log files, then it needs to keep up with the attack. This may be used to flood the IPS. We have a demo showing this. In this case, we have two attackers. One is doing the flooding, and the other is running a SIP enumeration attack while the flooding is happening. This attack is usually blocked using fail to ban. So first we SSH to the target server, run screen and then htop to monitor the system. We check if asterisk is running. So start asterisk and in another window start fail to ban. The system is on the internet, so what you're seeing in the console is some other attack which is not related to the demo from someone else. So anyway, we can switch to the attacker machine and run a vicious SIP enumeration attack, and we notice that the attack is correctly blocked with fail to ban. Following that, we can unblock the IP so that we can actually demo the flooding of the IPS. So we SSH to the second attacker machine and run a vicious SIP DoS flood attack on the target, this time using options as the method. And at the same time, we run the SIP enumeration attack again and see that it is not blocked. So if we switch to the attacker to the target machine, we can see that asterisk is generating a lot of logs, and also if we look at htop, asterisk and fail to ban are both high on CPU usage. So that's it for DoS on security protection. Please watch the next video, which is about evading security protection and discussion of solutions.